This section explains the Lora model and code implementation. Let's first look at the Lora model overview. Lora is a technique for efficiently fine-tuning large-scale pre-trained models by introducing low-rank trainable matrices into existing layers while keeping the original weights frozen. This approach reduces the number of trainable parameters and memory footprint while maintaining expressive power. Key idea: instead of updating the full weight matrix W, we approximate the change using two smaller matrices as follows. Rank is much smaller than input-output dimensions. Mathematical derivation. 1. Standard linear layer. In a traditional neural network, a linear transformation is given by as follows. During fine-tuning, W is updated, requiring significant memory and computation. 2. Lora formulation. Instead of updating W, Lora freezes it and introduces a learnable low-rank decomposition. A project's input to a smaller space, B maps back to the original output space. 3. Scaling factor for stability. To balance the contribution of Lora, we introduce a scaling factor alpha as follows. Ensures stability when training with low-rank updates. Now we implement the Lora code. Lora layer class. Linear with Lora class. Testing the Lora.